Hi, so today we're doing 14.1, finding limits using tables and graphs. So we're going to be learning the table method of how to find a limit, and the limit is basically just asking, as we approach this x value, what's the y value? So using a table, we always want to use three values to the left and right of the number we're approaching. So number left to 3 is 2, but we want something even closer than that. So something even closer to 3 is 2.99. Something even closer is 2.999, and then 2.9999. To the left would be 4, but even closer is like 3.0001, 3.001, and 3.01. So these are from the left, and these are from the right. Now I'm going to plug these numbers in for x in the original function. So I want to do this in the calculator, and it would be like 5 times 2.99 squared. And plugging that in, I would get 44.701. I'm going to save us some time and write down these answers. So 44.97, 44.997, 45.0003, 45.03, and 45.3. Now we're looking between the left and the right. As we come up from the left and from the right, we're approaching the number 45. So the limit as x approaches 3 of 5x squared equals 45. Next is x squared minus 4 over x minus 2. So again, let's write numbers to the left and the right as we're approaching 2. So of 2. So 1.99, 1.999, 1.9999. And then to the right would be 2.0001, 2.001, 2.01. So from the left and the right. Again, we're going to plug it in the same to the calculator, but remember you're plugging in 1.99 for both x's in that original equation. So we would get 3.99, 3.999, 3.9999, 4.0001, 4.001, 4.01. So coming from the left and the right, our limit is 4. Looking at B, we would do the same thing with our table. However, another way we can do these is just plug in 2 into the function. So 2 plus 2 equals 4. So I may specifically ask you to use the table method, and you want to use the table method, or you can just try plugging in the number. How this one in A is related, because if we take A, if we had plugged in 2, we would have 2 minus 2 on the bottom, which gives us 0. And a 0 on the bottom means undefined. But what we could do next is factor the top. It's a difference of 2 squares. And we could have factored this as x minus 2 out our x minus 2's, and just been with that x plus 2 like in B. So that's how these two are related. Then moving on to one with the trig function. So whenever you have a trig function in the limit, you always want to make sure that your calculator is in radians. That's your first step. But now we're going to go back to normal using the table method, because if I did plug in 0 here, I would have it in the denominator, and you can't have 0 in the denominator. So let's do our table from the left and the right. A number to the left of 0 is like, let's just do negative 0.05, negative 0.02, negative 0.01, and then the positives of those for the right. So it doesn't really matter what these numbers are in your table. They just need to be less than 1 away from the number you're approaching. So these are the left, and these are the right. Again, make sure your calculator is in radians, and then go ahead and plug in, and we would get 0.001. 0.99958, 0.99993, 0.9998, and then 0.9998, 0.99993, 0.99958. So coming from the left and the right, our limit is 1. Now going to the last two, these are using a graph method because we have a piecewise function here. The way we want to find the limit of the piecewise function is always by graphing the two pieces and then finding the limit based on what the graph looks like. So let's go ahead and graph these two pieces of the function. The first one is the equation y equals 3x minus 2. So that means we're going to start at the y-intercept of -2, and then our slope is 3. So we're going to go up 3 over 2. So 1, 2, 3 over 1, 1, 2, 3 over 1, and then so on. But what we know right here on the function, originally it said that x can equal 2. So at x equals 2, I'm going to go ahead and put an open circle there. Now I'm going to graph the second piece. Oh, forgot to make my line going through my points. Yeah, that looks good enough. Okay, so then the next piece is y equals 3, but it's only at x equals 2. So that means it's a point at 3, 2. So 2, 3. 2, 3. So I'm going to go ahead at 2, 3, put a point. And now I can find the limit. So again, we're coming from the left side and the right side. So the point doesn't have a left or a right side. It's just a point. So that means we're going to look at our linear line. So coming from the left side, as we get to x equals 2, because that's what we're trying to find the limit of, the y value is 4. So the left equals 4. Now looking at the right side, as we come from the right side, we also again get to that same y value of 4. Makes sense because it's the same line. So the limit, since the left and the right are the same, equals 4. So the limit as x approaches 2 of f of x equals 4. All right, last one. We're going to go ahead and graph those two pieces again. The first piece is the equation y equals x, which is your linear line, but it's only when x is less than or equal to 0. So I'm only going to graph the portion that is less than 0. So starting at x equals 0, but going less than. And at 0 would be a closed hole because it's less than or equal to. The second piece is y equals 1. So I would graph my equation y equals 1, which is a horizontal line, but it's only when x is greater than 0. So I'm only going to graph the portion when x is greater than 0. And there would be an open hole because it's not equal to. Now I can find the limit. So coming from the left of 0 is the linear function because there's no left on the constant. And when I get to x equals 0, my y value is 0 there. So the left equals 0. Now looking from the right. From the right of 0 is my constant function. And when I come to x equals 0 from the constant function, my y value at 0 is 1. And the left and the right are not equal to each other. So that means the limit does not exist. So since the limit from the left, I don't know what I just spelled, from the left and right are not the same, the limit does not exist. And that's it. Let me know if you have any questions.